All right, so we're gonna run these guys through an abbreviated version of one of my dynamic effort setups. Okay, so for this, we're gonna be chasing a goal of 0.7 meters per second. Now, they're gonna blow past that, at least for the first few sets, and you're gonna see how we make adjustments to that. These are essentially gonna be warm-ups for them, and again, they're my former athletes, so I don't think they wanna kill themselves on a Sunday for, for any of this. But as you can see here, we've got a plate, a metal plate down on the ground. That's gonna act as the base for the magnets on our OVR velocity unit, okay? The screen is hooked up on there, so if I had a side spotter right here, they could see this screen. They could verbally cue the athlete and say, you know, hey, 0.68, 69, 70. So the athlete can hear instantly what number they got and know where they are in context to what they're chasing. Additionally, we're going to try and keep this so that it's lined up where when he takes a step back and goes down to the box, that tether is as straight up and down as it can be. We've tried to even it out in as far as spacing it away from the rack, so that again it's straight up and down in all angles as much as it can possibly be. We've taken the strap, we hold on to it firmly, put it around. We're going outside of the dumbbell or outside of the weights for this. In between sets, if we need to adjust the weight, we can take that off, quickly put it back on. But we don't want to put it in too far, too close to these hooks, too close inside of the bar. Now with this again, we're using a safety squat bar. This safety squat bar has a camber right here. It has an angle, it dips down. What that's gonna do mechanically is it's gonna alter our squat a little bit. You'll see when DJ goes to get under this bar, that the weight is gonna swing forward, okay? That's gonna activate and stress him basically from the back of his head all the way down, versus if it was simply a regular straight bar back squat, you'd only would be working really from the point of contact down. So this is gonna get that upper spine up into the head and neck, have everything working, everything pushing. And that camber as well is going to take the center of gravity and shift it a little farther forward. So it's gonna be somewhere in between a front squat and a back squat in terms of the feel and effect. But it's gonna make it mechanically maybe 5 to 15% harder. And of course, as you keep adding weight, the magnitude of that effect from the camber is gonna, amplify exponentially as you add weight out here. It's gonna start trying to twist against him and trying to break his form down faster and faster as the weight goes up. So we're just gonna do a set of 3 here to get the ball rolling, start warming up. We've got the app set up here so I can see easily from behind. He's gonna sit down, come to a complete stop, explode up. 101 there, so he's blowing through that 0.710. Let's see how fast we can go on this one. 1-1, real fast. All right, so as you can see, this is basically a warm-up weight for DJ. All right, but you see he sat down into that box. Again, this box for DJ, gonna be probably pretty close to parallel, maybe a little bit below this hard box here. On top of the hard box, we've got a soft foam pad. When he sits down to that foam and comes back up, that foam is it's gonna deform and accept his force into it. But when he comes up off of it, it's going to reform slower than he could come up. So he's coming up right now at over 1 meter per second on average. That foam is expanding very, very slowly. It's still reforming from when I just pressed it down. So if DJ were to try and lift that slow enough for the foam to give him some push back, some bounce back, return that energy to him, he would 100% fail because you simply just can't contract that slow. Now Titus is gonna come up. Again, far different body type, much different athlete. There we go. He's gonna do the same thing. He's gonna squat down and back to the box, come to a complete stop, fire up. And right off the bat, he matches DJ with a 1-1. 105. 1-0. So these guys, again, all relatively strong athletes, all guys who've squatted over 500 pounds at some point. So, and all relatively mature, all in their 20s. So we're going to be using a higher threshold today to try and hit. 0.7, there we go. 0.9, okay. 0.9 again, drive through. 9.2. All right, and again, we already see differences. Adam, former collegiate baseball player, he's strong, he's thick. He's not really built too much different from Titus in terms of height, and their weights are probably, close enough to be relatively comparable, but different types of athletes. So he creates his force a little bit slower, and it kind of makes sense if you've watched our jumping videos, where Titus gets off the ground extremely, high and fast, creates a ton of force. So it makes sense here that he moves the same weight a little bit faster. All right, so we all hit over well more than a tenth on that one. So we would undo our clips here and add some weight. And so we're going to return the tether to the bottom. We're not just going to take it off and let it snap down. And there we go. I'll let DJ load that plate up. So now we've got, this is a 61-pound bar, so this is 241 pounds. No one likes to carry that extra one, but I do it. Let's see. Full stop, explodes up, 0.84. 0.85. 0.80. Right? So our goal is 0.7. So DJ broke through that easily. So DJ will add weight on the next set. There you go. Walk back. 9.1. Easy. 8.3. 8.1. All right, so Titus easily broke through that 0.7. They're both well over a tenth, over 2/10 on their fastest rep. Let's see what Adam does here. 0.75. 0.69. 0.69. So that's a great example. Adam would already basically be at his working weight. Now, can Adam move more weight than that faster? Obviously, but it's still relatively early. We've done a lot today, so he's either tired or we just took a break, so maybe he needs to warm back up. But so we'll continue going. For Titus and DJ, we're going to add substantially more weight. So y'all want to go up? 25? Okay. So again, what we're trying to do here, we're going to add 50 pounds in total for those guys. That's a 35?
Proceed to add 70 pounds.
We're going to misload the bar for them. We're going to add 50 more pounds for their next set. Again, these are two guys who've squatted a lot of weight before, and they're kind of used to this style of training. So we're going to add that tether back. Oh. We're going to add that tether back. And we're going to see now, they were each over 2/10 of a meter per second fast on their last set. So now you can also see, we're rolling through this relatively fast right now. In an ordinary setting, we might take, if our goal is to maintain a high speed, we might take, as strong as these guys are, 5-6 minutes. They might even take even longer, given their age. So younger athletes, weaker athletes, you can take less time. As the weights get bigger, they're going to take more out of you. Okay, so as the weights get bigger, if your main focus is output, maximal speed, maximal weight, maximal speeds at the highest weights that you can get to, then you're going to need appropriate rest. So If you're Dave Hoff, for example, you might need 15, 20 minutes in between sets. But if you're, mere mortals, 5, 6 minutes is probably going to be tons for even your strong high school athletes. All right, so let's see it. And when you've got a good rotation of 3 or 4 different people, it's usually going to build in enough rest kind of on its own. There we go, 0.72. 0.62, all right. Drive through the last one. Drive through. Ah. The camber got him. The camber got him. And you can see DJ's got a long torso. He's a tall kid. So all that camber, it's hard to keep everything tight. All right, let's see. A3. 7-3, 6-8. All right, so once again, we've reached speeds where it's probably appropriate now for them to start taking very small jumps. Titus hit a 0.83, so he definitely is strong enough to take a small jump. And for that jump, it'd probably be something like 5 to 10 pounds extra. He hit a 0.83. He's an older athlete. I know roughly where he's at. We would throw on 5 pounds on each side, okay? For DJ, who struggled a little bit more, he might be able to throw on 5 more pounds on each side, take a 10-pound jump, but you're probably gonna see that he would have a harder and harder time as we went through keeping up. For Adam, he hit the speeds on 1 rep, on the set before, so he wouldn't even take this jump here. We would take a lesser jump. But even though he might be just as strong as them in a maximal sense, right now, what we're trying to work on is a combination of rate of force development. That's why we're using the box jump. And we're trying to keep it in that sub-maximal zone. So we're trying to create power and use this as dynamic effort. So if I had even younger athletes, smaller athletes, weaker athletes, what I do with my high school kids a lot, or my middle school kids, is they're not going to be able to express very much weight at these higher speeds. So we're going to take them down, maybe to 0.5, 0.6, and go probably more of a brief maximal tension route with them, even, and go below 0.5, get down in that 0.4 range. We're going to try and keep them above 0.3 though. So that's how we can use VBT and the feedback from it to dial in specific to what type of athlete you are. Of course, if you were a real advanced power lifter where your maximal effort might be a gear or two slower than everyone else and also considerably heavier than everyone else, you might be working more as 0.7 might be your heaviest week, right? The old Louis Simmons 0.9 to 0.7 meters per second, 75 to 85% top weight, with only 50% of that weight being in barbell, in plate form, and the rest being accommodating resistance. The reason for that is that those athletes create so much more stress at the weights and the outputs that they're at. So to accommodate for that and make that make sense for their whole week so that they can simply recover and survive to the next workout, their max effort is slower, so their dynamic effort has to be faster. So they might work at 0.7 to 0.9. I'll work my kids more where that average is around 0.6, so kind of 0.5 to 0.7. And if you had younger, weaker, or less trained kids, you might be working more around that 0.5 as an average number. So that's how we would do it for squats and dynamic effort.